Hello, I'm Dr. Thomas Haney, and welcome to the first introductory lecture of programming with objects. Um, Possibly the entire module is going to be in C Sharp, but I think we'll try and squeeze in a little bit of C++ as well. As before, you've got all my contact details, my email address. The fact that I'm in room E359 is irrelevant on the Paisley campus at this moment in time. But you also have my mobile number, which is 0771 267 3509. So this is a sort of brief overview to the module. So really an introductory programming module in C Sharp. Possibly we will venture into C++. And essentially it's to teach you elementary programming skills. So we're going to cover some of the basic concepts demonstrated in a console-based application. And then we'll talk about general input and output with some processing in between. Okay. So some of the concepts will be your basic building blocks of the software application, such as we'll look at algorithms, blocks, truth, if statements, logical conditions, compound conditions, switch statements, while loops, for loops, the game loop arrays, simple data structures as well, perhaps. And it's also to teach you the importance of object-oriented programming in computer games development and computer games technology. There's absolutely no pressure associated with this, but if you don't, it is the industry standard to sort of understand object-oriented programming, and if you don't understand it, then chances of you getting a job are fairly sort of minimal. Outside my apartment at the moment, there seems to be a person with a pneumatic drill. It's slightly distracting me a little bit, but we'll persevere. If I were in the university at this point, I'd be doing a lecture, probably, sure as fate, there'd be someone outside with a leaf blower. These people that are employed to move leaves from one location to another instead of pick them up and dispose of them. Anyway, I digress. So we're going to be looking at abstraction, encapsulation, classes, objects. We'll talk about designing a class diagram using UML notation, so class diagrams as well. Developing a class structure for a computer game so that you're introduced to object-oriented programming relatively early and it becomes second nature to you. We may look at other diagrams as well, possibly sequence diagrams in UML and use case diagrams. They seem to be the sort of simplest ones. So that you can look at the construct objects of games and categorize them based on their functionality and behavior. So since last year, I've made some changes to the module, which were quite well received, I've got to say, 2 years ago, but since the last sort of iteration of the module. And I've included some things on software components and graphical user interface implementation, so that's always sort of good to know. So even though you may not be a sort of games programmer, basically designing apps and things like that and graphical user interfaces, sort of sensible applications will be second nature to you more than anything else. So that's the plan. Next. New integrations, we could possibly do a little bit of GitHub, and we're going to perhaps put a little bit of more emphasis on debugging this time, although I don't imagine how we're going to do that from afar. Possibly we might take that out. But we'll look at graphical user interface principles. I'll put in a lecture about that, and we'll focus on things like user-centered design, directness of manipulation, metaphors, consistency, appropriate feedback, aesthetics, forgiveness, simplicity and human memory, limitations and system sort of messages. So in order to sort of slightly go through some of these, I mean, you do know what some of these are anyway, you encounter them in your everyday life. Metaphors, for example, the recycling bin is a metaphor. The desktop itself is a metaphor, so that you can relate it to something in real life. Consistency through a graphical user interface system is sort of key. If it's not consistent or it changes, then you get confused, it's not necessarily intuitive, and you can't use it. You need appropriate feedback at the time in order for it to be usable and workable for you. It's got to have some degree of forgiveness as well. That's why you get a little message popping up saying, are you sure you wish to delete this file? And you're really, really 100% certain, because I believe in a Linux system, if you say delete something, it's just gone. And that's it. There's no takesy backsies, and that's a bit of a thing. Simplicity as well. I don't know if some of you are going to be looking at the Maya interface, but you just look at that and think, oh my god, cognitive overload, I have no idea what's going to happen, because it's such a complex piece of software. Although it's award winning, I believe, but simplicity in graphical user interfacing systems is quite key. Human memory limitations, that's really associated with a thing called chunking. So essentially, if you have a human, they can process 7 plus or minus 2 pieces of information on a menu. Any more than that, and then we get totally and utterly confused. So you've got to sort of keep that in mind as well. System messages, you've got to have system messages that are relatable. So to simply say an error of 3.159 has occurred means absolutely nothing to anyone. So it's got to be sort of human in that respect. So possible implementations of more simplistic computer games, if we get to that as well, we'll look at that sort of thing as well. So it's going to be a relatively interesting sort of module. Okay? Engagement, you're expected to watch the lecture each week. Once again, let me know about your opinion of the delivery. I'll put a video up. I'll also put up the bare slides, and you can let me know how you feel about that. Next week, you'll start to get small lab exercises to perform. As I've sort of said in the overview video, we're going to be using Microsoft Visual Studio 2019 Community Edition, which is freely downloadable, and everything should be hunky-dory. Essentially, we should be doing, or you should be doing, about 10 hours of study per module. And I would recommend that for this. I mean, there's not always going to be 10 hours of work. But you should sort of go over it, make sure you know it, make sure it's second nature. And you've got to be able to complete the assessments in trimester 2, and you're not going to be able to do that unless you actually engage with the labs that I'm going to provide. And they are relatively simple in the sense that I spell out absolutely everything. So if you can't follow them, it's because you're not looking in enough detail. I've made them completely and utterly idiot-proof. You have to keep up, as it's the core module. You're all computer games development first year students, I believe, in this module, and this is a core module worth 30 credits. As I've tried to belabor before, you require 120 credits at each level in order to get your degree, and if you fail this module, it's a core module, and you won't be able to progress until you've actually passed it. Okay? But it's an easy module. It runs both trimesters, trimester 1 and trimester 2, and it's just a question of keeping up and letting the knowledge seep in ever so slowly but ever so surely. And that's really what programming is about. So trying not to make you experience cognitive overload in that respect. So possible assessment information, let's see, we'll do a class test. I always sort of do a nice class test, which is multiple choice. I go over that quite extensively, so the marks associated with this are relatively high. I've implemented a little game this year specifically for that purpose as well, so I'll give you access to that. And there's also lab exercises that are worth 20%. Okay, so some small programming exercises. We've got a BMI calculator because I'm a gym buff. Guess the number, easy peasy for loops. And then there's a sort of Mario Kart menu selection thing, which is a little bit more complex, but I quite like it, and it's worth 10%. There's a coursework as well associated with it, which is basically going to be the implementation of a menu using a previously implemented data structure as well. Now what I mean by that is that C# has a number of data structures associated with it, so I think there's stacks, and there's lists, and there's queues. So you can actually use their implementation of this. You're instantiating an object, of that particular class, and you're actually going to be using it for your own purposes. And that's what programming is all about. You're taking things that people have already previously programmed, the functionality is already there, and you use it for your own purposes, or part of that purpose. Okay? Creating some classes and some objects. So the beauty of all of this is that you can actually define your own classes and your own objects. It is marvelous. That is the beauty of object-oriented programming. Saving these to a file and reading them back from a file as well. So that's going to be persistence. Okay. Right. Contact details. As you know, I'm Dr. Thomas Haney, Tommy or Tom, whatever you care to call me. Everything is there. My email address, some of you have emailed me already, and my mobile number, if you have any difficulty or problem. I realise that millennials don't really like talking on the phone, but some of you might prefer that mechanism. Some people actually do phone the office when I'm in the university. Not often, but they do. So feel free to give me a call. I might not always answer because I'm sometimes in other calls as well, but do leave a message and I'll try to get back to you as soon as I can. I'm inundated with lots of emails and things at the moment, so you just have to be patient with me. If I haven't got back to you within about a 48-hour period, then please try to contact me again or just phone me, okay? I'm the Year 1 and Year 4 leader of computer games development, and I'm the program leader of the entire program as well. So all materials will be made available through Aula. So in terms of yourselves, your Year 1, so overview, all of that, and I'm also the leader of the program, so I'm your god, essentially, or supreme overlord. That's what I quite like. I'm trying to skip to the next slide. Okay, so 24 teaching weeks. There's 2 trimesters associated with it. Now, it's not a heavy assessment for this. I realise that some of the modules are a bit off balance in terms of trimesters. But anyway, this is a nice sort of easy get into it programming course, giving you as much information as you can possibly absorb without taxing you too much. So, 2 trimesters, 30 credits, obviously 10 plus 20. And the beauty of that is, when you feel that I've bombarded you with enough information or too much information, just feel free to say, can we have a break this week? We need to sort of look back and things, that sort of thing. So it's pretty easy, really. The class content is constantly being revised and will be exposed on a weekly basis, always on a Thursday at 10, because I've always done this module on a Thursday, physically anyway. Okay, so now I'm doing it remotely. I'm trying to stick to that particular timetable, otherwise it's going to be a nightmare. Okay, texts. Always nice to have one programming book, I think, associated with a module. So C# Player's Guide, 3rd edition by R.B. Whittaker. You don't necessarily have to purchase this book, but you can get it from that sort of Amazon link. The 2nd edition is fine as well. There's a C# Programming Yellow Book by Rob Mills. I can make that available on Aula. Essentially, if you're looking for that book online, probably the best thing to do, as we computing people often do, is write in the title and say PDF, and it might actually come up for free. Probably will. That is piracy, an infringement of copyright. But you should purchase it legitimately, of course. And that's kind of what it looks like, okay? It's a reasonable book. It's quite fun to go through. Doesn't really matter about the versions. Essentially, the underlying code is always generally the same, particularly when you're doing sort of rudimentary courses. Okay. Computer programming. I will also put on Aula today Masters of Education that I've just recently completed, and it is all about problems associated with programming in terms of pedagogy. So how do you teach programming? How do people learn programming? It's a very, very difficult, complex skill with many pedagogical issues associated with it. So you can have a read of that this week, because there are going to be no labs. It's just a sort of introduction. Considerable time is required to effectively learn the skill, maintain it and keep it up to date. Some people take to programming like a duck to water and they just intrinsically love it. And others not so much, I'm afraid. So you have to sort of decide whether it's for you. I did a degree in software engineering and then a master's degree in advanced computer systems development. And then I sort of decided, I can't take the stress of this. Well, it's not that. I mean, you're thinking to yourself, am I always wanting to, compile code, and I'm always wanting code to compile, otherwise I'm chain smoking and I'm losing the company. Wasn't for me. I preferred to sort of go into academia, but that's something for you guys to consider. You are trying to be games developers. It doesn't necessarily mean an awful lot of programming, particularly when you're looking at the engines and things like that. But you may also be software developers as well. So think about it. Rigorous computing programming has been introduced by the Department of Education in recent years, with programming being proposed as a skill that everyone should have. Yes, everyone should have, but it is a difficult skill and not everyone has it. So I always remember a few years ago there was a physicist in my class who could write out the secrets of the universe on a whiteboard, but could he program? No. Could he? Hell. And it was actually weird to see. But wait a minute, you understand complex issues that are far beyond my comprehension, but you can't seem to get this hello world program to work. It's amazing. So it's not entirely for everyone. It can be seen as a glamorous path to employment. It kind of depends on what kind of a person you are. If you're intrinsically motivated and do things for the enjoyment of it, then fair enough. But if you're actually wanting a bit of cash, money, then obviously you're going to quit all of this and turn to crime and just sell cocaine. Don't do that. But it is a glamorous path to employment. You always find work as a programmer. People constantly need them. So if you're wanting money, it's a good, noble path. You can also sort of slightly make it bigger. A lot of people have. Almost all students enrolled in a department related to computer science or a computer related field have to do a rudimentary programming class, and it's extremely important. Okay, so I assume that you'll all be sort of technologically literate and computer literate and be able to do some programming, okay? Despite the fact that employment opportunities for computer scientists are rising, the number of students enrolling on and graduating from computer science related courses is declining. So that's something to bear in mind. The majority of the attrition takes place in the first 2 years of a degree program. So people think, particularly with a sort of program like this, they play computer games and think, this is cool, this is going to be amazing to try and develop all of this. Then they realise that developing a computer game and actually playing a computer game are two very, very vastly different things. You can get a bit of an education, so and decide that it's possibly not for you, but I assume that you're all quite set in what you're wanting to do. Fewer students are actually choosing a career in computer science or engineering, and I have got to say that I am very, very happy that I decided to do a PhD in computer science. Because a lot of my sort of scientist PhD friends, although they look down their nose at me and they say, you're not a real scientist. They're not really a sort of real scientist. It's up for debate what computer science actually is. I mean, it's not like a sort of real science in terms of chemistry, physics. It's not viewed in that sort of light. But it is a sort of, pseudoscience perhaps, and it intermingles with social science and all that sort of thing. So real scientists sort of look down their nose a wee bit at you. But on the flip side of the coin, they make themselves so disgustingly specialised that finding a job is sort of slightly difficult for them. Whereas computing is forever, and they always need people that understand computers, and that's great. So I've always been quite happy, finding a job, always been happy in a job, that sort of thing. And sometimes they have struggled, these real scientists, until they find the appropriate vocation for them. And it depends what they specialise in. So there's a disparity in the number of graduates in employment, and unfulfilled or unfilled positions in related industries. So that's something to take into account. There are a number of identified issues associated with computer programming, with the result being a sort of programming incompetency, as graduates don't necessarily meet the industry expectations in terms of competence and capabilities. My friend, who has basically been a senior developer for a number of years, spends all of his time going around fixing the junior developers' code. That's all he really, really does. and I went into academia, and I'm, oh, terrible to say this, but I'm relatively thin in shape. I have all my hair. I'm not a bloated alcoholic suicide, but he has come close. He barely goes to the gym. He's putting on weight by the day, that sort of thing. And all he really does is fix all of the underlings, their code in the department where he works. So we both did master's degrees up to a point. I went into academia. He went into programming. It can be very, very good if you like it, but then it can be very, very sort of stressful. Okay? Not trying to put you off, but that's reality. Teaching introductory program is a multifaceted problem encompassing issues of abstraction. People have difficulties with the concept of abstraction. We will discuss that at a later lecture. Algorithmic thinking, software construction and debugging strategies befuddle people. Or at least these are some of the most sort of popular things. Computer programming courses are perceived as extremely difficult for some bizarre reason. Some people just reject the entire idea of having to work with computers, and you've met these people in life. They generally tend to be the older generation, where they sort of tend to say, oh no, oh no, I want nothing to do with that. But really, once you sort of put your mind to it and be patient, it's fine. High levels of attrition, that means that a lot of people drop out. Dietz and Bai state that novice programmers often struggle with many concepts underlying computer programming, and these are some of them. Variables, the misinterpretation of program states and variable states remains a frequent source of errors. And it takes approximately 10 years to turn a novice programmer into an expert. So it is a very detailed, specific sort of profession, and it requires an awful lot of discipline and work. And some people find it easier than others. Okay, other things they find difficult: confusion with branching and locations within programming logic, difficulties in the composition and coordination of programming components as well, understanding error messages to appropriately debug programs as well. Thinking in a programming syntax is often quite difficult, requires thinking in an operational level of abstraction before the production of code. Difficulty in the visualization of the programming constructs for given problems. And learners require well-structured, sort of timely feedback in order to get responses to their actions. So those are a few of the problems. Mind you, it can lead to a highly rewarding career. We have people like Alan Turing. Did he crack the Enigma code or something? Yes, I believe he did. And then we have Margaret Hamilton, one of the main computer scientists associated with the flight to the shuttle to the moon. And there is the sort of NASA, I believe it's the NASA guidance system code or something to take people to the moon. Or was it Apollo? What was it? Was it Apollo? Let's just check. I looked it up earlier. Actual Apollo guidance computer source code. Okay, so that's it. I'm sorry about that. Just to get that right for you. And you can imagine, I mean, writing all of that code, and we think we're hard done by sort of nerds. Bill Gates, he's obviously made billions. Tim Berners-Lee, and Mark Zuckerberg, the guy that has inadvertently connected us all and ruined all of our lives with Facebook or Facebook, whatever you want to call it. So a software engineer, and he's obviously made billions as well, and a software engineer can at the moment earn between about £25,000 and £59,000. Now, you will invariably sort of stretch your budget to what you earn. I mean, I used to earn £10,325. I now earn £48,000, and I'm constantly phoning up my mother saying I'm skint. What have you done with all your money? Well, I spent it in protein bars and consoles and things, because basically I'm just a large child in a just a child in a 40-year-old's body. Okay, so here's some computer programming salaries. JP Morgan, Jason Co, 44k. BAE Systems, 30k. Bloomberg, 63k. The BBC, 32k. Amazon, 47k. Facebook, £71,000. And you sort of need that in order to get an appropriate sort of life together. I would say that £50,000 is what I sort of need for basic survival. I'm not even joking about that. What has happened to my slideshow? What's happened? Okay. No, I don't want that yet. Okay, so my slideshow sort of conked out there, sorry. So, game developers, average video game programmer salary in the United Kingdom is about £31,000. Unity developers, 41. Unreal developer, 60, because it's more complex, because there's C++ involved. If you work for Nintendo, you're looking at $115,000 a year. If they manage to survive constantly being sued over their joysticks. But I think they will. They've survived this length of time. Sony PlayStation, £50,000. Xbox developer, it seems to be a £500 pay cut for that. But anyway, so the thing to remember is, in the words of my favourite, one of my favourite comedians, it's true that money can't buy happiness, but somehow it's much more comfortable crying in a Porsche than on a bicycle. So you really need to decide whether you're an intrinsically motivated person doing things for the joy, or extrinsically motivated doing things for a tangible reward, which could be money, but yet at the same time can buy some joy, you know. Okay, computer systems come in various sort of different categorizations. So we've got specialized, so you get things like an MP3 player, or you did back in the day, a video games console is specialized, although they are sort of branching out into different things as well. The PlayStation, for example, now can run all your apps and Disney Plus and all that sort of thing. A calculator is also another example of a specialized system. Washing machines, microwaves, aircrafts, a specialized system, space shuttles, morphine dispensers, and these smart watches as well. I've got one of those, and of course these things are software engineers and games developers. Every line of code that you write is important. I mean, when you consider something as important as a morphine dispenser, if you get something wrong, you could in fact kill someone. Now, computers are everywhere, and computer errors happen. They do, we'll talk about software failure at a later date, but they do cost lives and a ton of money. So we also get generalized, the PC, the Mac notebook, iPads. The line is becoming quite blurred now, because you've got things like iPads, tablets, mobile phones, and they incorporate everything into one thing. I'm not entirely certain that that's good, because you can actually run more or less everything from a phone. But anyway, in all cases, the operation can be generalized as the following: input, process, and output. At least that's how you should simplistically sort of think about it. Now, that will be on your class test: input, process, output. Okay, so do remember that bit. Software is a set of instructions given to a computer. So you've got your sort of specialized MP3 decode, control, maths functions, computer games, graphics, sound, simplistic logic. The general purpose packages such as databases, spreadsheets, Word, the bits of software as well. All computers need an operating system, software that controls all the interaction. PCs tend to use Windows. We've got Linux, Unix, iOS, whatever nowadays, and Android applications. And you'll kind of notice, well, I've certainly noticed within my lifetime, that these software systems, these operating systems are getting far, far, far more complex. And okay, when they run well, but I mean, at some points, they are immensely irritating. For example, when Windows 10 just decides, oh no, I'm updating now, and you look, but wait, I need to work. And it just sort of does it. And because they're so disgustingly complex, they always seem as if they're working all the time. You can go out and buy a great big huge beast of a laptop or a PC, and you can always hear in the background, what is it doing? Everything, essentially. So the OS provides the basic input-output, shell functions, hosts the application programs such as word processing. Then we have mobile operating systems, smartphones, tablets, and PDAs, if that's still a sort of term. And these combine the features of PC operating systems and other features, particularly for mobile systems. So you have a touch screen nowadays, Bluetooth, video camera, GPS, voice recorder, and then you've got things like Android, iOS. iOS is just gone to number 14, I believe, or version 14. I'm not really sure which one Android is on, but it's to host all of these apps. And nowadays we have sort of app overloads. We've got Facebook, Twitter, YouTube, LinkedIn, WhatsApp, Snapchat, you name it. You've got an app for absolutely everything. I'm not entirely certain that it's a good thing, because I mean, absolutely everything is app controlled. Even when you're going into places like Pure Gym, you've got to download the app and you've got to become computer literate and sort of work with that. And kids nowadays, even adults, will be walking down the street like this. You know, they don't see you, even in the days of COVID, and they just walk towards you like little chickens, and you've got to go, watch where you're going. And even another thing, when you're going into restaurants, at the time of the pandemic as well, you've got to download the app and order from the app, and everything is an app, and you do have a bit of cognitive overload because you're going, God, what app do I actually have to work with now? I can't remember. So I'm not entirely certain whether it's a sort of good thing. I do get confused myself. Every now and again I just go, oh, what app is it this time? So everything's online and, in your phone and an app. So that's the sort of latest, the iPhone 11 and the Samsung sort of S20, and everything is app related. And everything is implemented into that sort of compartmentalized functionality of an app. Okay. Computer programs, processors obey simple instructions. They add, subtract, and simple arithmetic. Compare values, look up values in a table, copy a block of data from one part of memory to another. And these instructions are called machine code. So it's very, very sort of basic constructs that these things all come from. And sort of transfer data to and from output devices as well. Takes a lot of machine code to do anything particularly useful, and the type of code is difficult to write and debug. And only very sort of fundamental parts of a system are done in this sort of way. So you get to appreciate just how complicated these applications are that you're constantly using, that are sort of intuitive and everything like that. How complex they are when you start to write your own programs and you think, how is this even remotely possible? How have people managed to come up with these fantastic applications? Okay. Since a computer is good doing trivial things repetitively, we use it to translate more functional code into machine code, so higher level. So you get higher level languages. So assembly language, still very low level. You get C, Pascal, Basic. You probably never have heard of these. COBOL, they were years ago, but now you get Visual Basic, macros, JavaScript, Python, and you, the programmer, will write high-level code, and a compiler or interpreter translates it into machine code. Okay. Go to my next screen. Okay, programming is not difficult in its own right. It comprises simple operations, maths, and organization. And users require more and more sort of flexibility and complexity in their software. So the scale of current software makes it difficult to control. Big programs have a lot of instructions, lots and lots and lots of things going on. And of course, it's best to think of everything in terms of the constituent parts as it is in life. The more I sort of project into the future, the more stressed I become. So it's better to sort of break that down into a day at a time, do what you have to, or focus on what you have to at that particular point. So it's compartmentalization, really. And it's the same with programming. So if you think of things in terms of the particular constituent parts, something with a few parts is simple. So we've got a mousetrap, it's supposed to be simple. Something with a lot of parts, a car, a plane, is very complex, but they are still composed of a whole bunch of simpler parts. So you've got to sort of bear that in mind. And computer programs are organized in that particular way as well. So you've got to be very good at organizing and compartmentalizing everything, and that's what encapsulation is really all about. So the complexity is how all the parts sort of fit together is really the issue that makes programming difficult. So management of complexity. How is complexity managed in other types of system? So let's have a look at a car, for example. A car has four main particular component parts. So we have the body, the engine, the transmission, the chassis. And each has several main components. So the engine has the ignition, the fuel system, cylinders, crank. Fuel system has the carburetor, the pump, the tank and the gauge. And when you break that down, the carburetor has the chamber, the float, the neo valve, the manifolds. So essentially, you're looking at it, compartmentalising it down into its basic constituent parts. So manage complexity by breaking down a complex system into assemblies, okay? And it's exactly the same with computer software. And we need to learn to join up these sort of simple bits. So input, process, output, I've already sort of said to you that this will be on your class test. It's probably one of the first questions on there, and it's a sort of multiple choice class test that I've always sort of formulated, and I will have, because it is a multiple choice, it will be shrouded in obfuscation. So there are little bits in there to confuse you. So it will simply be, how can a simple program be decomposed? And then it will say something like A, input, process, output. B, process, output, input. C, output, process. You know, things like that in order to sort of confuse. And you'd be surprised how many people actually get that wrong. So do memorize that slide. In designing computer software, we should aim to model any part of a program as a sort of input, process, output subsystem. So games are absolutely no different. Games are pieces of software, albeit probably more complex pieces of software. However, it's input. There's someone pressing the PlayStation. Oh, I've got a PlayStation 4 controller myself. It's here. Oh, it's quite interesting working from home now because you do have all these things. You don't need them on the screen. So there we go. We press a button, a process happens, and there's a wee mime there about to get hit by a baseball bat. So, why should you become a programmer? It really depends on what you're wanting to sort of do with your life. But think about it. I mean, it doesn't necessarily have to, come up with you don't have to come up with an answer today. But job availability, you've seen what's happening during COVID-19. People are losing their jobs. It's tough times for people, particularly in the hospitality industry. When I was young, one of the main sort of, or the travel industry as well, when I was young, one of the main sort of things was, if you're a pilot, you've got it made for life. And now look at what's happening, because all the aviation companies are sort of going belly up, and people that have trained to become, pilots and whatnot are finding themselves out of a job. But, I mean, you will always be able to sit at home and code, and it doesn't matter where. You could be employed by a company in Singapore, and because of the brilliance of the internet, you're connected to that all the time, okay? So it's a hard, specialised skill, very, very difficult as well. Well, that's what it means. It's very hard and very, very difficult, very specialised, and only certain people can actually do it. And they've got to be of a particular type. You get the sort of code monkeys, and then you get the sort of design people, and then you get people that couldn't code their way out of a paper bag. Can be very high paying as well. An average programmer will probably be about £50,000. There is flexibility in terms of working from home. We're all having to sort of work from home at the moment. And all you do is sit and code all day, providing you have a sophisticated enough machine. It's challenging as well. One thing you don't necessarily want to do is end up in a menial, well, it depends on what you're wanting in life, but you don't necessarily want to end up in a menial job that doesn't challenge you. And if it does challenge you, all the better. You wouldn't necessarily realise that time is passing in your day, but if it doesn't challenge you, you'll be watching the minutes of the clock, the seconds, and oh God, is this ever going to end? So it can be very challenging. It can give you the art of creation. There's a bit of poetic license associated with it. It can sometimes be cool depending on what you're programming, and you can get a lot of sort of kudos for that. But reasons not to be a programmer: if you don't like programming, you would be surprised how many people actually manage to get through a computer games degree and say, I don't like programming. Oh my God, how did it happen? I've even seen people going through software engineering degrees and saying, I don't like programming. Now, you can like it to a certain degree. You get people that are obsessed by it, and then people that are not so obsessed by it and think to themselves, why in the name of God does it make any difference whether this is a dot or a semicolon? Who cares? Why can't it just interpret it for me? You have to constantly update your skills. You have to constantly update your skills in everything nowadays. So unfortunately, it's just one of those things. Management, if you get into management, you might not want to be a programmer anymore. Overtime, it requires an awful lot of overtime, perhaps depending on what you're implementing. I didn't get into programming fully because I am entirely obsessed. I'm a crazed perfectionist when it comes to certain things, and I hate things to beat me. And I remember doing a module called Abstraction and Specification in Program Development in my second year of university, and I was up to 3, maybe 4 o'clock in the morning trying to recursively remove a node from a binary tree. And trying to get the code working was driving me nuts. Anyway, I found out that it wasn't in fact myself that had made the mistake. It was my friend, who's now the senior developer, who had screwed up the insertion algorithm, and that was the slight difficulty. The nodes being inserted into the tree weren't being inserted quite correctly, so therefore the removal algorithm didn't work. And I remember about 4 o'clock in the morning, scribbling into a little notepad, "Stuart is an ass." And I thought to myself, if I have a job like this, I will never sleep again. But never mind, I decided not. So, programming skills, these are skills that are sort of crucial if you're going to be a programmer or a games developer. Problem solving, you can't let every problem get you upset. You've got to be very, very sort of patient. You've got to be willing to debug and fix problems. Determination and perseverance, you've got to be the mindset of, nothing must beat me, but I will be calm about it. Everything will be fine as long as I just simply concentrate. The amount of sort of students that I've seen on a sort of yearly basis in the lab that will call me over and say, "I can't get this to work. Can't get it to work. What's going on? What's going on?" And that's absolutely fine. And then they scroll through the code as quickly as possible with the main priority of trying to confuse me enough that I go, "Right, get out of the way, I'll do it for you." You've got to be able to, and then eventually say, "Stop scrolling, stop it." Look at it carefully and patiently, and actually read what you've done, interpret and understand. So I had a sort of similar thing yesterday. I went to, because Apple has updated their iOS to version 14 or something like that, my friend was having who's an elderly gentleman, was having a difficulty importing his photographs. Normally what would happen was he would just simply put the dongle into the iPad and it would instantly come up with, "Would you like to import your photographs?" And he would select import and everything would be fine. But ever since the software upgrade, this import had not in fact appeared. And eventually we sort of got to it. He kept on, sort of telling me what had happened. "Well, I've been on the internet and I can't find any problem, because if it was a problem with everyone, it would be all over the internet," which is true. And we're experiencing that with some Amazon Alexis. She's over there. I shouldn't speak her name at the moment. So if it is a sort of big problem for the population, it appears on the internet fairly quickly, and you can get that. So he was telling me all about that. And then he says, "But normally I put it in here. I think it might be the connection problem or something like that with the connector." And then eventually I had to say, "Shh, just be quiet. Would you please let me just work my magic? And I'll have a look through it. And you've got to be patient, breathe. If you're going to continuously prattle to me, you're just going to distract me. So would you please be silent and just let me do it?" So eventually I sort of discovered that underneath devices, it was an untitled device or unidentified device, and he was able to import his photographs that way. But essentially what had happened was the graphical user interface had sort of slightly updated, and these things are supposed to be so intuitive that no one decided to have any form of instruction for the elderly. So, yes, you've always got to be patient and take a breath and go through these things slowly and carefully. You're constantly learning, you've got to be willing to research, you've got to be able to experiment, you've got to be a relatively good communicator as well. Writing specification documents, there's product release, writing tests and test code as well, and it has to be a bit of an obsession. And if you enjoy that obsession, if you enjoy that obsessive lifestyle, then it's for you. And very, very, very few people, I find it very, very difficult to detach from my job, even in academia at the moment. So, game programmer skills, enthusiasm, you've got to work on projects of your own and put them together into your e-portfolio. So have a look at LinkedIn, connect with me on LinkedIn as well. You're always learning. You have an insatiable lust for learning. Magazines, journals, all to do with C and C++. The pragmatic programmer recommends that you should learn one programming language per year, and that will keep you more or less sort of current. So the very idea, you're not going to be, shall we say, a secondary school teacher, because they get to a certain sort of level and then they don't necessarily have to learn anything ever again. They recycle the same information again and again and again. But if you're actually working in this sort of thing, then you have to not recycle your knowledge, but relearn things and constantly update your knowledge, okay? So there are different websites, different sort of professional bodies that you should look at in order to keep that relatively current. You should play games, have an appreciation of the finished product. I play games just for the research purposes, really. Playing, designing, developing games are completely different. Skills, C#, C++, 3D linear algebra, software engineering, good practices, that sort of thing. Ability to get things done. Now, that is the thing about a degree. A grade point average, which is good over a 4-year period, shows commitment and that you have the ability to get things done and stick to something, even though you don't necessarily enjoy every single solitary minute of it. Because you could very, very well just go away and learn things in Udemy and all that sort of thing, but you don't have that sort of formal qualification at the end that says, I've done this, I've stuck with this for 4 years and I did it. So it's the ability to commit to things, okay? You've also got to show that you've got a sort of well-rounded education as a game programmer, so you've got to have some hobbies, evidence of a life beyond computer games. One of the best programmers that I decided to, well, I was helping to write a reference to get a job, and then we got to the hobbies section of, what do you do? Play games. You go, yes, but do you do anything else? And eventually I managed to coax out of him that he did archery like 3 or 4 years ago, and that was what we put down as his hobby. So you've got to have a well-rounded education, I suppose. So it's like, I don't know if you're familiar with Blackadder, you're probably not. I am, on the other hand, a fully rounded human being with a degree from the University of Life, a diploma from the School of Hard Knocks, and 3 gold stars from the kindergarten of getting the kicked out of me. So you've got to be sort of fully rounded, and I believe that all of you people probably will be. And allows you to approach different problems or problems from a different sort of approach. Game programming is demanding as it pushes the programmer to the limits, and the hardware to its limits as well at some stages. It can be extremely satisfying, and you will find employment as a computer programmer, if not in the games industry, through hard work, dedication, perseverance, promoting yourself, which Scottish people hate to do, and positivity. Everyone loves positivity, regardless of the fact that positivity may be false. They prefer a positive, can-do, go-get-em attitude more than anything else, rather than negativity. No one likes anyone that's negative anymore, in employment anyway. So, how to learn programming? Listen to someone talk about programming. Watching someone program, there's tons of sort of YouTube videos and tutorials and things like that. Reading a book about programming, so these are all sort of mechanisms. Talking about programming, planning a program, and looking at someone else's program and seeing how that sort of differs from your own. But the main fundamental way to do it is just to do it by programming. And that's what we're going to slightly do in this course. So next week, we'll look at the basics of C#, how to construct a basic program in Visual Studio. So that's Visual Studio 2019 Community Edition. So possibly there's going to be instructions next week on how to download it. I've got them in a bunch of slides, and hopefully you'll be able to download the software and use it quite readily. And hopefully you can get a free version sort of working at home. The lab time will be used to make sure that you can create your first program, which is always a hello world, to such an extent that Visual Studio now has just a set hello world program, and that's what sort of comes up in the template. So there's going to be no labs this week. Do have a look at this. I'll put up that Masters of Education for you to look at, and you can see about the difficulties associated with programming education, and read all of it, particularly chapter 3, chapter 4. Read it all. It's only about 90 odd pages. And then we will start the lab work next week and try to get into that as much as possible. And we'll just slowly, iteratively, incrementally chip away at it. And hopefully it won't be too mentally draining on you. Hopefully a relatively enjoyable experience. And then that will consolidate and synthesize your knowledge of programming a little more that you've learned it over the year. And we might add in some C++ and possibly some, we're definitely going to look at graphical user interface implementation as well. And that would appear to be the end of the slideshow. I will make these bare slides available on the Aula system, and I will also upload this video, and you can watch me talk through the slides. Again, I'm quite interested in your feedback. Think about the assessment to see if you're okay with the proposed assessment, and also if you're okay with this sort of level of delivery in terms of me sort of talking through the slides. I think it's sort of nicer, and I do sort of get into it a little more when I'm walking about and that sort of thing, rather than just being a talking head. So that's really it for today. Again, welcome to the module, and I wish you every success. I'm sure that everyone will be fine. Here you go. Right, bye-bye.